Hello everyone. Today I got this this distribution amplifier from Spectracom. So basically, right now I want to set up a frequency standard reference frequency of 10 megahertz for my lab, and I was looking for a distribution amplifier, and I got one. This one. So this has two inputs. Let me turn on the back. So it has two reference inputs, reference A and B, and it has 12 outputs. And the nice thing about this amplifier or distribution amplifier is it has modes, like you can select either if 10 megahertz from input A or input B, or auto means if any one of the 10 megahertz is not working, then it will switch over to automatically. So this is the ready signals, whether the input is ready or not. And there are alarms, like if both A and B clock is not working, then there will be a major alarm, and if either of the one clock is not available, then it will be a minor alarm. So there is not much inside. So this has multiple variants, and this is AC and standard 10 megahertz. It comes with a different frequency also. So let's go through the schematic. It's pretty basic device. So it has two inputs, A and B, AC coupling, isolation transformer, and it has a logic, and the same clock pulse is going to 12 different outputs, and each output has LC filter. And I don't see this transformer on the PCB, but it has AC coupling, and it has option to have floating output or the output reference to the ground. So there are identical 12 outputs, and you can see, let me zoom in. So these are the LC filter. So there is supposed to be a transformer here, but it's bypassed. This is what it is as it comes with the device. Not much on this amplifier. So I connected. Let me give power and see how it works. Okay, so power is on. So you can see the power is on. So this A and B, so there is now a major alarm because there is no clock input. And if you input the clock, then this alarm will go away. So I check the input and outputs, it works. That means it's functional. I have a plan to have a GPS reference clock for my lab. So my plan for this guy is I'm gonna put this Trimble Thunderbolt GPS, which has this is the antenna input, and which has the 10 megahertz output, GPS disciplined clock oscillator, and it has PPS output, and you can connect to the PC, and you can control, you can configure, you can monitor the device status. So my plan is I'm planning to put this Thunderbolt inside this 19-inch this box, and then after connect and have option of the RF input on from the back, and also the 10 megahertz output, so that I can loop back to the input and use a single device as a standard frequency reference for my lab. Yeah, for modification of this unit, I think I need to make another hole over here just for the BNC log. There is one already existing hole for the DC, and I just make it slightly bigger to fit in the one BNC connector. So it will be for RF, and I will have another hole drill over here to have the 10 megahertz output, and I will loop back to the either A or B. So my plan is one input will be the GPS disciplined clock, and one input will be um, um, oven clock. From I do have one from HP, so that if GPS clock is somehow it's not working, then it will switch over between the quartz oscillator and the GPS clock. So I made two new holes, this one too. So I'm gonna use one for the RF input, one for the 10 megahertz output, and one for the 1 PPS output. So for now I didn't have this BNC connector, so I will just keep this hole closed for now. And now next step is I'm gonna think about how I gonna place this Thunderbolt GPS this guy inside the case. Okay, I almost finished this project. So I installed the Trimble Thunderbolt E GPS receiver and the timing output. It has 10 megahertz output. I put two BNC connectors. I tapped the AC wire from here, and then I fixed this AC adapter, and this will be the antenna input. This will be the 10 megahertz output. I'm planning to have 1 PPS output on this one, but I didn't have the BNC connector, so I just I used this blank right now. I feed this clock to the input, and I think pretty much this looks like this. Now if I give to the power and turn it on, let's see what happens. Okay, no fire. Okay, let me turn this on this side. Okay, and power it on. See, interesting. Okay, so you turn it on. So there is a selection is on A. The B is off. This is in auto mode. So there is a clock signals on A. So there is minor alarm because there is no clock on the B. And if I change the input to the B, then it will go to the signal B. Let's see. Okay, B. Okay, now it says, yeah, so when I connect 10 megahertz input to the B, then B lights up and there is no clock on the A. So for example, if I connect both A and B, then both lights should turn on, and it will have a failure transfer between A and B depending upon the availability of the clock. So looks good so far. Now I'm gonna need to pack it up, and it will go to the my 19-inch rack. So hopefully it should work as planned.